Hello everyone, welcome to my YouTube channel again. So in today's video, I would like to introduce a problem I run into in the weekly contest 30 of LintCode. Okay, so this problem is called the judge give problems, and I think it is interesting. So I would like to share it with everyone. Okay, so I will introduce what we need to solve in this problem first. So there are three kinds of question, which is simple question, medium question, difficult question, just like we saw in LeetCode. Okay, so uh, a hoster of the contester need to hold up the contest, but there are some rules needed to be limited on their question. So assume that there are E sample questions, M medium questions, and H difficult questions. And here are not another two questions, which is EM and MH. What does this two kind of question mean? It means that EM, if the problems belong to EM, it can belong to type of E, and it can also belong to type of M. And MH is also can belong to type of M and type of H. Okay, so here are actually 5 types of question they can use now. And for the hoster, the rule for the contest, they need to have at least one easy, one medium, and one difficult in each contest. So in this condition, how can they get the maximized number of the contest on the limited question in their library? So for the input, here are number of E question in libraries, and 2 question for median, 1 question for difficult, 2 question for EM question, and 2 question for MH level. Okay, and at this condition, the maximized number of contests they can hold up according to the this rule is 3. Okay, so now we need to get the maximized number. So when I ran into this question, at first I come up with the idea. So um, here are, okay, I will write down my idea here. So first, at first there are E question, M question, H question. Okay. Another thing I forgot to say is that here we can see the time complexity is so big, right? Okay, EM and match. So I assume that EM we can separate it to E1 plus M1. MH can be separated to M2 plus H2. Okay, so now we can say that we have E with E plus E1 question, M with M plus M1, H with oh wait, here another plus M2, right? So H with H2. So now we have changed the problem to like this condition. After we separate EM and MH kind of question. Okay, so now we know that uh, the hoster can hold up at least mean minimum value between uh, e plus e1, m plus m1 plus m2, h plus h2. And this is what we also want to maximize. Our goal is to maximize the minimum value between e plus e1, m plus m1, m plus m2, and h plus h2. Okay, so this is our goal. However, I stuck in this place in the contest because this is so difficult to maximize this kind of goal function, objective function. There are almost have five types of parameters, and you need to find the maximized value between them, between the minimum value between them. So this is a very difficult question. So in this way, this is very difficult to solve this problem. So we need to change another way. How to solve this problem? Uh, First, after I found this input size is so big, even uh so big and over uh 10 times of 10. So it also means that if we want to avoid the problem of time limited existed, we need to use some way that can handle this problem in big O log n. It means that we need to handle this problem with such kind of solution. And when you see this kind of time complexity, what comes to my mind is only binary search. Okay, so to get binary search to handle this problem with binary search, what we to do is to guess how much problem can the host of the contester maximize, organize it. Okay, so now we can convert this problem to just as uh, problem to guess the maximized value. So I would like to handle this problem in this way. So now we can just remove this part. We won't use this way to solve the problem. We'll use binary search. Okay. Okay, so handle this problem with binary search. Let me think. Okay, so we need a left value and a right value. So left. Okay, wait a second. Uh, so left left value and right value. We just need to set with max. Okay. Hmm. How about I use? It might be okay. Uh, Not this way. And with binary search, you need a mid and mm, This is our mid value, and we will use this mid value to guess our number of contest hold. If we will create another check function to check whether we can hold up such number of contest. So this is long number, and then long e long. Let me make a copy of paste here. And okay, so this function will return true if he find that yes, we are capable of holding such number of contests, and return false vice versa. So if it return true, then we will continue. F equal to mid plus 1. However, if it return false, means that we cannot hold up any more contests, then we will stop it. Okay. So after, let me pass into the parameter mid e em m mh h. Okay, and then we will need to return right. So we also need to check that, because if it find out, it will first uh let mid plus 1, and if he find that if it uh fail to satisfy the function, so the last value of left value might be fail, so we need to check, we also need to check it again in our return value. So here might be check and check left value e em m mh h, and if it return true, then we will return left. If not, we return left minus 1. Okay, I will discuss at this place again, because here binary search. So this ways of binary search, he have size 2 of the searching space, and if uh if the value of left is allowed to hold up the contest, so it will just continue to move right on the searching space. And why I need to check about it again at here is that the left can be out of boundary in this way. So if mid is already at the end of the boundary, then if I add one more on the mid, and left will be out of boundary, so I will need to check about left can satisfy our condition or not. If left cannot satisfy, it might already out of boundary, then what we need for our answer is to minus 1 to make it back to the boundary. This is what I work on in our return value. Okay, so now let's back to the most important part in this program about the check function. Okay, so the check function, how to check whether we can hold up such number of the contest. First, uh, we will check if number is bigger than. Okay. So I assume that if we put only em to the e, all because en can be belong to easy level, right? So if we put all of em into e, and even we put all of them into it, it still cannot bigger than num. It means that we must not can hold up such number of contests, right? Even we put all of the em level question into e, we still cannot hold up. However, we need to get the minimum value between three types, right? So if this cannot be satisfied, then we will just need to return false directory. But if we can satisfy, oh, I will write up three condition first. If for the it is also same work for the hard level of question. If we put all of the mh level into hard level question, this is h plus hm. Oh, mh. We just need to return false directory. Makes sense, right? However, if it works, then what we need to do next is to uh, make three levels of question to be the try our best to make the three level of question to be at the same number. So here I will need to make em minus the number of the difference between uh, m minus e. Okay, and same at here. Mh minus mid. Okay, so here is the condition if num smaller than num smaller than easy smaller if hard smaller than you will need to take em plus num minus e here um mh minus equal to minus h. Okay, then next step is if number. Okay, I will explain here first. For this part, so now we know three level of question need to all of them need to satisfy the condition for For easy type of question, they need to be at least number of num, right? Because if we want to hold up, assume that I want to hold up number of question, number of contest. So there should be at least uh, number of easy, number of medium, and number of hard level question, right? So we need to check if easy currently is smaller than number. We need to take the number from the easy medium level to make it satisfy the question. And it is also same for the medium level and hard level to be at least number of the question. Okay, so now uh we already take part of question from medium hard level and already take part of question from medium hard level. So we need to check. Now we know that if we take work this way, and easy can satisfy the condition, and hard level can satisfy the condition, and the rest is we need to check whether median satisfy the condition. So here we might need to if median satisfy the condition. Okay, so if number is bigger than the median number, and the rest part of m, and the rest part of the mh, we just need to return false directly. Okay. Okay, so it should be our check function. Let me check about it. So mm, here is still some problem. Let me think about it. I think if EM is not enough to support our easy question, it also means that it cannot support us to hold up such number of contests. So here I might also need to check whether mm, whether EM is smaller than 0. Yes. If EM smaller than 0 and return false. And here, if mh smaller than 0, we also need to return false. Yes. Okay, so this means that even we have, in this case, why I need to check these two? Because in some cases we have large number of median level question. So even large number of median level question, even they minus my if we get negative number here, and even a large number of median question minus some negative plus some negative number is still bigger than the number, so it will still work, right? However, uh, we cannot make these things happen because the number of question cannot be negative number, right? It doesn't make sense. So yes, I think this is all part of our check function. Okay, let me run again. Hmm. Hmm. Let me try to submit it. Okay. Okay. So it seems that I got accepted for my solution. So I think uh, this is very interesting question. And even though the question seems not so easy, but I think you should come up with the idea of binary search very easily, because when we run into a problem, we should also observe the input size of the data. And from the data, we can also to derive which kind of time complexity we need to handle this problem. So in this problem, I find that for the large data, we must use the time complexity of O log n to avoid the problem of time limited consecutive. And the way is binary search to guess the maximize number of the contest. Okay. So if you have any problem about how I solve this problem, and also about this tricky part, I think many people might forget to handle this thing here. And I think I don't need to talk about how to write about this template of the binary search. You can find three kind of type binary search template in LintCode binary library. Okay, so you also need to check about the left value is out of boundary or not. Okay, so this is my today's video. If you have any problem and comments or want to correct what I share about my idea in the video, welcome to leave any comments. Goodbye.